All right, I need to finish a twin with y'all. That's my goal, and I guess I'm at the bonus questions if I remember right. Yeah. Find the domain of the composite function f composed of g of x when f of x is 10 over x plus 10 and g of x is 10 over x. All right, so this is going to go right there. Now, if I just write out what I have, I can tell you real quick right here that x cannot be 0. Because if x was 0, we'd be attempting to divide by 0. Now, we're going to have to clean this thing up, make it look a little better. So I'm going to focus on 10 over x plus 10. What I'm going to do is I'm going to x both pieces. That'll give me, the x's cancel, they'll give me 10 plus 10x. So moving forward, I'm sitting at 10 over 10 plus 10x. I did that to make it look a little bit different. And now I can see something else that I can't be. At least I can see it. But I know that 10 plus 10x cannot be 0. So 10x cannot be 10. And x cannot be, negative 10, negative 1. So these are the two things I've learned. X can't be 0. X can't be negative 1. That's really all there is to it. But I'll probably do this with, this is most likely done over here in interval notation. So if I can't be 0 and I can't be negative 1, I could be negative infinity all the way to negative 1, unioned with negative 1 to 0, and then 0 to infinity. That'd be my final answer. Number 18 is pretty simple. 18, divide that guy by that guy. We're dividing by x minus 5, so x is 5. Just use placeholders and synthetics. Let's see, we'll have 1, x cubed, x squared, x 625. And we drop, and we multiply, and we add, and we multiply, and we add, and we multiply again, and we add. I was expecting this to come out to be, well, this is just horrible. I guess it's not a perfect one here. And we multiply, and we add, which is going to be 1250. Remainder, constant, x squared, x cubed. So after we do the division, we'll have x cubed plus 5x squared plus 25x plus 125 plus 1250 pieces of x minus 5. Moving forward, really easy problem actually. I don't know what kind of challenge question that was. All right, compute the discriminant and determine the number and types of solutions for the equations. The discriminant was b squared minus 4ac if equal to 0, 1 repeated real, b squared minus 4ac if greater than 0, 2 real, unique, and b squared minus 4ac, it's supposed to be 0, and greater than 0. Milbrath. Less than 0, 2 complex conjugates, aka imaginary. So first thing you'll do is you put it in OSTD form, 6x squared plus 8x plus 7. And b is going to be 8, so 8 squared minus 4 times a, which is 6, times c, which is 7. You got 64 minus 24, 140. Lost my place. 168, which is definitely less than 0. So there are 2 imaginary complex conjugates. Well, that's what's there. All right, number 20, solve the system of equations. We have x minus 3 equals twice y, and x squared minus xy equals 20. And this should be pretty straightforward for those of you who have any idea what's going on in algebra. We're just going to solve this one for x. So x is going to be 2y plus a 3. And everywhere I see an x, I'm going to become that. So here I have 2y plus a 3 that is squared minus 2y plus a 3 times a y, and it's 20. If I square 2y, I'd have 4y squared plus 12y plus 9. Seems right. Do the distributive property here. Take away 2y squared plus 3y, still equal to 20. Still combining of like terms. 4y squared minus 2y squared is 2y squared. 12y minus 3y is going to be 9y. And then if we move the 20 back to the left, 9 minus 20 is minus 11, equal to 0. And let's see if we made something that factors. Takes a 2y and a y to make 2y squared. Let's try an 11 here and a 2 there. Sorry, and a 1. Because, 11 times 1 is 11. So yeah, it looks like it factors to me. We want to be positive 9, so plus 11 minus 2 equal to 0. And we now have our y values. Y minus 1 is 0, y is 1. And this one, if we do 2y plus 11 is 0, we'll get y is negative 11 halves. So there's my two y values. I just plug them back in right here to get my x values. So x is going to be 2 times a 1 plus a 3, which is 5. I'm going to have an ordered pair over here of 5, 1. And if I plug in my negative 11 halves, x is 2 times negative 11 halves plus a 3. 2's cancel. Negative 11 and 3 makes negative 8. And my other ordered pair is negative 8 and negative 11 halves. It wasn't too bad. 2 more to go. Come on. There we go. We got logarithms. Solve the logarithmic equation. Be sure to reject any value that is not in the domain of the original logarithmic expression and give the exact answer. So you probably don't remember things like this, but a log of AB over CD is log A plus log B minus log C minus log D. That's how you condense. So this is addition. It's going to become multiplication. We're going to have a log of 3. The numerator is going to be x plus 6 times x minus 6. And we have a minus, which is division, or equal to 2. X plus 6 times x minus 6 is going to be x squared minus 36. Our base is going to be 3. Its exponent is 2. So x squared minus 36 over x is 9. We're going to x both sides. X squared minus 36 is equal to 9x. We're going to shift that 9x over. X squared minus 9x minus 36 is 0. We're going to, attempt to factor? I guess so. Factors 36, probably 12 and 3. That'll work. We'll do a minus 12 and a plus 3. This will tell me that x is 12 or x is negative 3. And fails. Fails. 4, a logarithm. Any argument, the argument must be bigger than 0. This guy is extraneous. This is the only answer. Plain and simple. And, all right, looks like there's one more to go. 4 to the x plus 4 is 5 to the 2x plus 5. What's the best thing to do on this one? Best thing to do on this one by hand, other than y1, y2, which you can do, is probably to ln both sides. Exponents to the front. We'll have an x plus 4 ln of 4 equal to 2x plus 5. Notice it's being wrapped because you have to use the distributive property. Natural log of x ln's of 4 plus 4 ln's of 4 is equal to 2x ln's of 5 plus 5 ln's of 5. And now I'm just going to take everything with an x and get it on this side over here. X ln's of 4 minus 2x ln's of 5 equals 5 ln's of 5 minus 4 ln's of 4. And I'm just going to, what I'm going to do here, I'm running out of time, is I'm going to pull the x and think about this as the natural log of 4 minus 2 natural logs of 5. So I'm going to divide out that ln of 4 minus 2 ln's of 5 from both sides. And there's my answer. Or something very similar to it. You could have moved your x's right and your numbers left. It's really up to you as to how you do it, but that's the answer the way I chose to do it. I wish I'd quit hitting that key. I think that's it. That is it. So there's the bonuses on your next test. You're welcome.